Okay, we're going to graph cotangent. And before we dive into this, we need to deal with the fact that our phase shift isn't as clean as we want it to be. We want to factor out a 1/2. And so to do that, just rewrite the function, but bring the 1/2 in front of the parenthesis. And then you need to divide. So to figure out what goes here, we're going to do pi over 4 divided by 1/2. Let's just kind of squeeze that over here. Remember, when you divide fractions, you rewrite the top and multiply by the reciprocal. And so that gives you 2 pi over 4, or pi over 2 if we reduce. Okay, so now we have a function that we can see a lot. We can see the b value is 1/2. Right here is where b is. And that gives us a period of pi over 2, of pi over 1/2, which is 2 pi. So with cotangent, it's a lot like tangent, where we do pi over b to find the period. So this is my period. Let's label that a little better. And then I'm going to have a reflection. I guess before we do that, the amplitude is none, because cotangent has no amplitude. The vertical stretch is just 1. However, I also have a reflection over the x-axis, so it's going to flip everything over. That's something I tend to forget about, so always pay close attention to that. Make sure you don't forget to flip the graph. And then this is going to move the graph right pi over 2. It's that phase shift, or that horizontal shift, and remember, that changes the sign of everything. Okay, so before we get too far into the graph, let's get the period down and split that into 4 equal parts, because that's the trend with every graph, is 4 equal parts. And this is a familiar number because it's 2 pi. That's sine and cosine, so we know those 4 equal parts, or hopefully we know these 4 equal parts. But divide 2 pi by 2 to get pi, divide that by 2 to get pi over 2, and then halfway between pi and 2 pi is 3 pi over 2. Okay, and then actually, let's use a highlighter for this. So usually we have a asymptote at 0 and then at the end of the period for cotangent. But we need to shift all these right pi over 2. And so let's go ahead and shift the asymptotes first. So that's going to shift the asymptote right over 2 pi over 2. And then if I add pi over 2 to 2 pi, I get 5 pi over 2. And so I'm going to have an asymptote here. So when you shift, your asymptote also shifts. And then this is what you can use as kind of a reference to sketch in your graph. Let's get rid of our old ones. So tangent, right in between the asymptote, it's going to hit what is kind of the midline, if you will, but kind of the middle of the curve, or the inflection point is a better name for it. And then typically, let's call this 1 and this -1. Typically, the point would be up here, and the function would go down, but this one's reflected over the x-axis, so it's going to be down here, and then up here. It's going to look a little bit more like a tangent curve. And that is your cotangent curve for this situation. The domain and range, we can talk about that. The domain's kind of tricky, but it does follow a pattern. It's always whatever the first asymptote is. It doesn't have to be the first, but it's best practice to use the first one, which is pi over 2, and then plus the distance to the next one. That distance, in this case, is always the period. So I'm just going to do 2 pi and then times n. So I could just keep adding 2 pi forever, and I would continue to land on a asymptote, which is a value that is not included in the domain. The range is all real numbers. The lowest value is -infinity, and it goes all the way up to +infinity. And that is graphing tangent with some transformations.